Hello, everybody. We are starting the webinar while we are still waiting a couple of seconds for people joining late. I can tell you a few words about our today's agenda. So first thing is there is a little green button on the bottom of the screen that will link you to our today webinar's materials. You'll find links to our Zuul installation, and you will also find a description of our today's workshop. And I will start with telling you a bit about the Zuul CI system, and then we will continue after about 20 or 30 minutes. We'll continue to a hands-on workshop where you will be able to write your first job in the Zuul CI system and look how it works. Okay, I think that we can wait a couple of seconds and then I will start the presentation. Hang on. Okay, hello again, everybody. We have 14 people online, and I think that we can start. My name is Jarek, and also with me there is Lucas, that will...
Hello, everyone.
This is Lucas. We both work at Codeline, and we use Zuul in our project. We are maintaining a Zuul installation for the Open Contrail, now renamed to Tungsten Fabric project. And I will be giving the presentation while Lucas will answer all your questions on the chat, which you can find on the side of the window. Okay, so I think that we can start right now. Okay, today we are going to talk about Zuul Continuous Integration System. And what is Zuul? It is a system that runs tests on your code. It checks okay, give me a second. Okay, let's try it this way. Okay, so I think that we can continue with this setup. Okay, sorry for the interruption. Okay, so we are going to tell you a few words about the Zuul CI system, which you can use to run tests on your code. Its purpose is to check commits going into your source code repositories. And this solution is self-hosted. There is no cloud installation that you can use right away. You need to install it, and you need to download it and install it on your own premise. And Zuul, important information is that Zuul is a strategic project of the OpenStack Foundation. So this is a serious project that is used every day in production, and it's quite a reliable solution. Okay, and speaking of the Zuul users, this is the main user is the OpenStack Foundation, and guys from the OpenStack infrastructure team are the authors of the system. And other organizations and companies are MediaWiki, OpenContrail, OpenLab, also BMW and GoDaddy. So this system, maybe it's not yet well known, but it's already used in production in large scale. And okay, so this is the first slide about how does the Zuul CI system work. And this is a simplified view. So the source of everything is a Git repo or a code review system. Usually this is Gerrit. And Zuul receives events from Gerrit. You can think about the events like a pull request created, or pull request changed, or a review that came to a pull request. Zuul receives the events, it reads its configuration, and decides which jobs should be run for the particular change. And for executing the jobs, Zuul is running Ansible playbooks on slave virtual machines. So this is the really simplified view. This is basically how most of the CI systems works. And let's go into some more details. The first step is an event that Zuul receives from the code review system. This event triggers all the later steps. So when Zuul receives an event from a Git repo, it consults its configuration. And the configuration in Zuul is not static. Zuul actually uses Git as a kind of a file system to read configuration files and to merge configuration files from different repos. So for example, you can have some configurations of your job in the source code repo that you are testing, but also some other jobs in other repositories that were prepared by other people. And Zuul can merge information from multiple repos and run the jobs accordingly. So after consulting the configuration stored in a Git repo, Zuul will prepare nodes to run the test job. And for this, Zuul sends a node request to a service called node pool. And node pool is responsible for spawning the test nodes to run our job. And the most usual backend for slaves is an OpenStack cluster. So node pool creates a virtual machine. It can be the node set used for a job. Can consist of multiple virtual machines, but usually this is a single VM. So node pool requests a VM creation from OpenStack, and a new, completely fresh slave VM is spawned and prepared for the job execution. Then node pool returns the node info like IP address, username to Zuul. And the next step is Zuul sends information about the job to a component called Zuul Executor, which is actually an Ansible control node that will run appropriate Ansible playbooks on the slave VM. So the job is executed on the slave VM prepared by Nodepool, and let's assume that the job succeeded, and the result is returned back to the code review systems. For example, saying that the pull request is fine to merge and that it passed the automatic testing. Okay, so this is the under the hood description of how Zuul executes its jobs, and now let's continue to description what are the strengths of Zuul and why it may be a good choice for your project. So first of all, a nice feature of Zuul is that it focuses on environments where you have very many projects. It has mechanisms for testing changes between different source code repos. And for example, you can tell Zuul, you can include information in your commit message that you require some other change from some other projects. And Zuul will take care of checking out all the changes in a single workspace directory, and the job will run including all the changes that you specified. So there's no manual intervention needed. Sometimes the solution for this is to, when you want to test two commits to two different repos in one workspace, sometimes the solution is to pause the execution of the CI test and for somebody to log into the machine and check out all the code and then continue the job. But Zuul does it everything for you, and totally without intervention of a CI administrator. One problem with this is that Zuul can't handle dependency cycles, so there is no way of specifying that a commit from repo A should depend on commit from repo B and the other way at the same time. So the commit from repo B depending on commit from repo A. This is not possible. So in case there is a need to include two changes at the same time from two different projects, you need to figure out a smart way of doing an incremental change that will allow you to do this. And this is an example of how OpenStack specifies the dependent changes for commits. You can include a hash ID of a different change in your commit message. So in this case, the upper change specifies the change ID of the lower change, and both of them will be checked out by Zuul into one workspace and tested at the same time. And here you can see how it looks like in the Zuul UI. So both of the changes are visible, are connected, and this means that the change number 46572 depends on change 46571, and they are both tested at the same time. Okay, next feature that is also related to working with multiple projects is gating. A gating feature is something that can be described as testing changes right before or even right after merging it into the target branch. So for example, when you have a pull request waiting for merging, the CI system will test it in a state when you uploaded it. Then you can, for example, wait a couple more days for a code review from your team member. And during this time, the target branch, for example, master, will drift away. There will be new commits added to the target branch. So the test performed by the automated CI system is like outdated. So after approving your change and after merging your change, there might be a situation when the CI system merges the change and it breaks the master branch. So Zuul, before each merge to the target branch, performs the tests again to make sure that the most current state of the code is tested. And if of course, if the tests fail, it will roll back the change and the change won't be merged. So this is a really solid way of making sure that the master branch stays valid at all times. And of course, during this gating phase, Zuul also honors the dependencies that I spoke about before. So if you specify that your change depends on a change from another project, Zuul will make sure that the change from the other project will be merged before your change, and it will preserve the order. This is one of the reasons that why the cyclic dependencies are not supported in Zuul. Okay, so another nice feature of Zuul is that you can share the configuration and share the jobs between different projects. When you specify a job in one of the projects that are in the same instance of Zuul, you can use it freely in other projects. So you can reuse code if you have multiple projects using the same technology, for example, the same frameworks, the same programming languages. So you can have a test job, a template test job that will run your testing tools, and you can reuse it between projects very easily. And this will reduce the work needed to set up a new project, because you don't have to duplicate the configuration. And the sharing is can be made in two ways. One way is to just share a job from another project. You can just use it and it will work. And the other way is you can extend a job from another project, because Zuul has an inheritance model of jobs. You can add some more steps to an already existing job, and it will also work. And the outcome of this feature is that you can easily share pipeline ownership between teams. So different team may be a maintainer of one repo in which you, for example, have deployment scripts. And this team may take care of the deployment scripts, and another team can be owner of the, for example, testing repo, integration testing repo, and they will take care of the Zuul jobs that are performing the integration testing. And yes, another and the last feature that I would like to talk about is the ephemeral or disposable slaves. So every job runs a new set of virtual machines. The virtual machines are clean, are spawned just before the start of every job. So you are using a clean environment, and this also makes sure that there are no manual changes required for running your jobs, because the base images can be really bare bones without any package installations, and all the dependencies should be resolved in the Zuul jobs. Of course, this is one of the approaches that you can take, and but by this approach, you ensure that all the dependencies are taken care of by your code and by your jobs. Okay, so we have a list of nice features of Zuul, and now I would like to compare some features of Jenkins, which may be the most known CI system to Zuul. So the slave pool in Jenkins is usually static. So you have statically configured slaves waiting for jobs, and they are also reused between jobs. In Zuul, they are entirely dynamic. There is a possibility to run your jobs on static slaves, but this is usually used only for testing. And there are bots. There are bots because Jenkins has lots of plugins. And for example, the Kubernetes plugin for Jenkins allows you to run jobs on ephemeral Kubernetes pods. So there are possibilities to extend Jenkins to achieve some of the functionalities of Zuul also. There's also a new project called Jenkins X, which runs entirely on a Kubernetes cluster, and the Kubernetes plugin is a default in Jenkins X. Okay, the configuration store for Jenkins, this may be done by the web interface or by manipulating XML configs under the hood of Jenkins. And in Zuul, the configuration is entirely stored in YAML files in Git. And as I said before, in Jenkins, the XML configuration is a kind of a configuration management, change this file and then reload the service. You need to do this to change the configuration. But in Zuul, Zuul directly uses the Git repo as a configuration store. So it also always uses the latest version of the code. And also when there is a change to one of the files from the configuration repos, Zuul can be notified and automatically reload its configuration. So this is storing configuration is in a source repo is very good. Of course, we have the tracking of history, and we can also easily recreate the service in case of some failure. This is taken to another level with Zuul because it even doesn't store. It even doesn't need to store the configuration on disk because it can connect to the Git repo URL and download files directly from it. And the job definition, the DSL, if somebody is familiar with Jenkins Groovy DSL, then it is used to define the jobs and the pipelines in Jenkins. And in Zuul, we use Ansible for everything. So to write a job, to write the contents of the job, you need to write an Ansible playbook and define tasks inside it. Sharing jobs between projects. In Jenkins, jobs usually belong to one project. And in Zuul, the sharing and the inheritance of jobs is encouraged. But of course, there is a way. In Jenkins, you can use shared pipeline libraries to share the Groovy code between projects. And Jenkins has a quite nice user interface, graphical user interface, and it has an interface for viewing logs, statistics, and configuration, while Zuul has really basic user interface. The interface is really basic. It does its job really good. I mean, when we have a status page that shows us the currently running jobs and currently queued jobs, and the user interface never failed me. I mean, it is really stable and it's really nice, but at the same time, it's really basic. So it has no additional features. While Jenkins is has a very rich plugin ecosystem where you can find plugins to display statistics from unit tests and things like this. So in Zuul, this is mostly do-it-yourself. And Jenkins has plenty of integrations. It can integrate with different code review systems and with different source code repos, while Zuul is mostly used in Gerrit setups. Gerrit is a code review application and also has support for GitHub. There are more integrations coming as there is more interest in Zuul, but for now, the most tested connection is the Gerrit one, and there's also support for GitHub. Okay, so first summary, when Zuul CI could be a really good fit for your team. when you have many interdependent projects and you really need to automatically test changes between each of them. So when you have too many situations when change going into one project fail code in other projects and break other tests, then the gating feature of Zuul may be really useful for you. And many independent teams also, because we manage all the job configuration in a Git repo, then you can use your usual repo permissions to tell who can change which parts of the system. And also many people can work at the same time on a single pipeline, which can greatly accelerate the work. And this is also a very good match for an open source project, because Zuul was prepared by the OpenStack team, as I said before, and there is a really big focus put on the security aspect. So in an open source project, you need to be aware that people from all around the world will come and will try to test the changes in your system. And it's nice to know that your CI system is hardened, so it will not expose infrastructure secrets, for example, to other users. And Zuul is also able to fulfill some very special requirements for build environments. So it can spawn any type of virtual machine. And if you require some very specific versions of operating systems, very specific versions of kernels, for example, then Zuul is very flexible in this area. For example, Circle CI already have a virtual machine type node, but it can only run their own distribution of Linux. There is only one version of the virtual machine image. So Zuul here is on-premise, but it can give you a very big flexibility in terms of the machines that run your jobs. Okay, and to sum up the downsides, there is no hosted solution. Similarly to Jenkins, the functionality out of the box is pretty bare bones, and most of the things for now you need to do on your own. Of course, you can reuse the job libraries from OpenStack, for example. They have a vast library of jobs that can do many things, but everything needs to be specified explicitly. For example, log uploading. There need to be a separate Ansible code to upload the logs. There is no automated out-of-the-box solution. Everything needs to be crafted and tailored to your use case. And the minimalistic UI, of course, many of the things are changing right now. For example, today we had upgrade of the UI for Zuul. It was rewritten, and there is really much work being done right now on Zuul, and this is it is evolving. And the most interesting things that are coming to Zuul are more integrations. We have there is a number of plugins that are currently in review for Zuul. For example, for Kubernetes cluster, for AWS, and for VMware clusters. There are deployment tools in the works. For example, you will be able to easily deploy Zuul using Docker Compose on your laptop or on Kubernetes. And there is also a container native workflow being designed for Zuul so that it will not be so bare bones anymore. It will have a native embedded workflow for building and testing containers also on Kubernetes and OpenShift. So more things to come. And now I would like to just show how the Zuul CI works. And you can go to the link that I provided on the bottom of the webinar page, and you can also see it on the screen. And there is a there is a manual, and all the steps are described here. I will perform the steps on my computer, and you can watch, or you can do the steps on your own and try it on your own. The webinar manual and our Zuul installation and the Git repos that are used during this webinar will be available during the night and during tomorrow, I guess. So you can also do some hacking after the webinar finishes, if you want. Okay, so let's start. We'll be working on a project called Sample Project that I created on GitHub right now. And the first step is to fork the project to your own user. Okay, I will, let me see. I need to change the screen sharing settings. Okay, I forked the. I will fork the project. Okay, so let's go to the project. Fork it. And now we have a fork of the project that we will be working on, and let's clone it. And let's make some test change just to see if this is working. Add. Let's create a new branch. Add our changes. And push it. Okay, it should now appear. In the repo, and we can create a pull request to the upstream projects. New branch. Okay. Okay, the pull request is created, and you can see that we created a GitHub application for this webinar. So we have a Zuul instance running, and the Zuul instance is connected to the sample project. So you can see that Zuul started executing the jobs, and the build succeeded with a job that does nothing right now. It's a no operation job that finishes with success in no time. And let's do something, and let's create our first job in Zuul. Now let's go back to the manual, and we'll create our first job in Zuul. For this, we need to add configuration to the Zuul YAML file inside the repo. So this will be job named my job, and it will have a associated Ansible playbook that will be called myjob.yaml. Okay, this is fine. Create the Ansible playbook. It will have two really simple tasks. One will print some message in the logs, and another one will execute the date command, which will show us the current date. So we hello world job. And the last thing, we need to tell Zuul that we want to run this job for every change in this repo. So include my job in the check pipeline for our project. Okay. Add the new files. And push it to the repo. Okay, you can see the commit going into the pull request, and Zuul received the event from GitHub, and it started testing the pull request in its new state. So with the new files included, we can go to the Zuul status page, where you can see, zoom in a little bit, where you can see that we have a queue, and in the queue we have our job, the one that we created right now. It is running. We can see the stream of the logs in the Zuul UI. Okay, and as you can see, the job succeeded. There is the no operation job that is running for every change, and there is also the new my job. And as you can see, Zuul is picking up the changes that are configured in the pull request. So you don't need to merge anything into the repo. You can test your CI jobs in the pull request, and once you are sure that they work well, only then you can merge them. So when you click on the name of the job, you will go to log directory for this job, and here you can find the same transcript of logs from the web console. And here there is a HTML report from a tool called Ara. This is a generic tool for making reports out of Ansible playbook executions. And here in Zuul is serving a very good role of showing us what happened with our job. And here you can see that both tasks from our jobs were executed. And here is the message. And the other one printed the current date onto the console. Okay, so this is working, but it's not very useful. So as the next step, let's show you how we can include other projects in the job in the CI configuration. We can change the tool configuration and the job to add a required project. In this case, this will be another project from my namespace. And to prove that this project is really visible in a workspace, let's add another task that will list the contents of the source directory in Zuul. So we will change the job, add one more command. So we can see the commit going into the repo. We can see it running. And here you can see that we now have another project in our workspace, so the dependency worked. And another project is located here. It contains, apart from the Zuul configuration, it contains a JSON file, which is a really badly written JSON file. And what we will do now, we will write a test that checks the validity of JSON files in the other repo. So this will be a first meaningful test in our pull request. So we can use one command to do this. We will be using the Python JSON module just to load the files, and it will return a non-zero code if the files are malformed. Okay, and we will execute it in the project directory of another project and see how it goes. We have our commit. There is also a link to the Zuul status page in the checks box. So we can go directly to the status from the GitHub pull request page. This status page has a link to the pull request. So clicking here will take you back to GitHub. Okay, let's wait for it to finish. And it failed, as expected. And Zuul reported back to GitHub that we had a failure in our job that is probably caused by the bad JSON file in the other repo. Yeah, let's wait a second for the logs to be available. Okay. And we can see in the Ansible report that we had 4 tasks and the 4th task failed. And it detected a syntax error in the JSON file. Okay, so the next thing to do is to fix the JSON file, but I will show you how to include dependencies from other projects without merging the code into the repo. So we don't have to commit anything to the repo. We don't need to merge anything to another project to test our job. We can prepare a fix and test it against our pull request. So I think that I already forked another project repo to my user. Okay, and the test file here is also broken. I will now clone the repo here and also create a new branch. And let's edit the file. Okay, edit. And push it. Okay, now GitHub suggests to create a pull request, which we'll do. Fix JSON file. This is pull request number 3. And now we would like to tell Zuul to test our pull request from sample project and to take this pull request from another project into the workspace so that our job can succeed. And we can do this by editing the description of the pull requests number 69 from sample project. And the description is the first comment of the pull request. So let's edit this and add a special definition of a dependent pull request. So this goes like this: depends on. We are telling Zuul that we depend on pull request number 3 from GitHub, and GitHub also automatically parses the comments, and it will also include information that Zuul tests number 69 reference to this pull request. So we have we'll have links to both the pull requests. And to retrigger the Zuul job, we can write magical command recheck. Zuul will receive information about this event, about the comment, and it will retrigger the job. So you can see that it started. And now on the status page, you can see that our sample project pull request depends on pull request number 3 from another project. This means that both of the changes will be available in the same workspace on the build machine. Okay, it looks like the critical task passed successfully. Okay, it finished. And we can see that all checks have passed, so this worked, and Zuul really took the changes from another pull request from GitHub. Let's see it in the RR report. We can also see that now the JSON file is the one that we added in the third pull request and not the one taken from the master branch. Okay, so this was a really quick demonstration of some of the neat features of Zuul. You could also see the web interface of Zuul and how it integrates with GitHub. And as I said, the scenario for the webinar is available on the zuulwebinar.codeline.com/info page. So you can perform all the steps on your own, just substitute the important parts with your username. So fork the projects into your own namespace and put your username here. And also you can use other names of commits, other names of branches, and try other things in the Ansible playbook. So you can play around with Zuul. It will be available till the end of tomorrow, I guess. And okay, hello Paul, nice to see you. And yeah, I hope you enjoyed this. If you have any questions, any more questions, I wasn't looking at the chat and Lucas was taking care of it, but if you have any more questions, you can ask them on the chat. And I want to invite you all to our Zuul presentation on the OpenStack Summit in Berlin in November. And the link to we will be talking about the Zuul system, Zuul CI system that we built for the Open Contrail project, which is now called Tungsten Fabric, and will be more in-depth description. This was a basic introduction, and on OpenStack Summit we'll go into more details. And of course, you can watch the presentation live, or you can see the recording afterwards if you can't make it. Okay, I hope that you enjoyed the demo, and see you on the OpenStack Summit in Berlin. Or if you have any more questions after the webinar, you can reach us via email. Our email addresses are also available on the Zuul info page at the very bottom. Okay, thank you very much, guys, and bye.